In process control and instrumentation, signal isolation is a key tool for keeping your systems accurate, stable, and reliable. At its core, signal isolation breaks the galvanic connection within a measurement circuit and/or separates a measurement signal from the rest of the process loop, preventing unwanted electrical interactions from interfering with your instruments. This helps ensure that the data your control systems rely on is true and consistent, even in complex or electrically noisy environments. Using the right signal interface instruments, whether you call them signal isolators, repeaters, or interfaces, helps prevent problems before they happen. These devices not only isolate signals, but they can also share, split, boost, protect, step down, linearize, and even digitize process signals, allowing transmitters and controllers to communicate seamlessly. Signal isolation became especially important when electronic transmitters replaced pneumatic transmitters. New electrical challenges such as plant noise and problematic grounding scenarios, which were not issues with pneumatic infrastructures, were introduced into measurement circuits. One of these common problems, the ground loop, continues to be a challenge today. Ground loops occur when DC signal wires, like a 4 to 20 milliamps loop from a differential pressure transmitter to a controller, have paths to ground at both ends. If the voltages at those two ground points are different, a circulating closed current can form through the wires and ground, introducing unpredictable amounts of current into your electrical signal. This can distort measurements and reduce the accuracy of your control system. A ground loop forms when three conditions are present. 1. There are two grounds. 2. The grounds are at different potentials. 3. A galvanic path exists between the grounds. Eliminating a ground loop requires rectifying at least one of these conditions. But in practice, the first two conditions are often unavoidable. You can't simply reduce the number of grounds, and it's often impossible to just lift a ground. Some grounds are essential for safety or exist because instruments are in contact with the process or grounded surfaces. That's why ground loops are one of the most common sources of signal inaccuracy, and why understanding them is critical in process control. So, how do we solve ground loops? The answer is simple. Use a signal isolator to break the galvanic path between the two grounds. By interrupting the direct electrical connection, current can no longer flow, even if there are still two grounds at different voltages. In other words, the ground loop is eliminated. The primary role of a signal isolator is to break this galvanic path, preventing unwanted current from distorting your measurements. A galvanic path is any direct electrical connection that allows current to flow between circuits. Breaking it can be accomplished in several ways, including electromagnetic, optical, capacitive, inductive, or even acoustic methods. In industrial applications, the most common methods are optical isolation and transformer isolation. Optical isolation uses light to transfer a signal between two parts of a circuit, completely separating them electrically. The key component is the optocoupler, a compact module that contains a light source and a photosensitive detector. The light source, usually an LED, acts as the transmitter, while the phototransistor serves as the receiver. The LED's light intensity determines the output signal, and the air gap between the two provides the galvanic separation that ensures full electrical isolation. Because no electrical connection exists, optical isolation offers excellent common mode noise rejection, is ideal for digital circuits, is not frequency sensitive, and is often smaller and capable of providing higher isolation levels than transformer isolation. The other widely used method for breaking the galvanic path is transformer isolation, also known as electromagnetic isolation. This technique uses a transformer to electromagnetically couple a signal across an air gap or other non-conductive barrier. The strength of the electromagnetic field is directly proportional to the input signal applied to the transformer. Transformers are extremely efficient and fast at transferring AC signals, but since many process control signals are DC, they must first be chopped into AC to pass through the transformer. Once transferred, the signal is then rectified and amplified back into the desired DC output. This method provides reliable isolation and signal integrity in many industrial measurement and control applications. In process control, you'll often hear the terms two-way isolation and three-way isolation. Understanding the difference is key to choosing the right signal isolator for your application. Two-way isolation refers to isolation between the input and output. It's common in two-wire transmitters, which are powered from either their input or output terminals. However, for four-wire isolators that require external power, such as 24 volts DC, 110 volts AC, or 220 volts AC, you need to make sure the device provides full three-way isolation. Three-way isolation means there's separation, and thus isolation, between input to output, power to input, and power to output. Without this, shared connections between power and signal circuits can allow common mode noise or even power supply failures to create unwanted output signal errors. Ensuring true three-way isolation helps maintain signal accuracy, noise immunity, and overall system reliability. Signal isolation is essential for keeping process measurements accurate, stable, and protected from unwanted electrical interference. Signal isolators, repeaters, converters, and interfaces work to break galvanic paths, eliminate ground loops, and ensure signals remain clean and reliable. Techniques like optical and transformer isolation provide safe, efficient ways to separate circuits, while three-way isolation offers full protection in line-powered systems. Signal isolation ensures your measurements stay true and your systems run smoothly.